Hello everyone, today we are going to discuss the concept of SR latch. So we will see the introduction to SR latch and latch in general. We'll discuss about SR latch and its application in this video. So latch converts its output according to its input instantly. Why do we have the word instantly? Because there are latches, there are flip-flops. Now, when it comes to latches, whenever the input changes, at the same instant the output changes. So, that is latch. Whereas, if to the latch we connect a clock, if controlled clock are connected to latch, then we call them flip-flop, and there the output changes whenever the clock signal changes. And we will see now shortly is cross-coupled logic gates can help us to implement the latches. And they are also useful to store single bit information, and that value can be held until new signals are given as input to override those values. Operate with signal levels and not signal transitions. When it comes to flip-flop, the signal transition happens at the input transitions. When the clock transits, then only the signal transition takes place, whereas we call latches as level triggered. We use the term level triggered for latches because whenever the level based on the input, based on the input level, the output changes. Okay, so now SR latch. SR stands for set reset. Either you can set or you can reset the latch, hence the name SR. S stands for set, R stands for reset. So using the SR, we can take the output to be either 0 or 1. If both S and R are at 1, the latch is undefined because we could have ambiguity whether the output is actually 0 or 1. Also known as preset and clear states. We have two states. We can also call them as preset and clear states. The SR latch forms the basic building block of all other types of flip-flops. We can construct different flip-flops by using the SR flip-flop. Okay, so now let us see how this actually works. So, very simple. Here the structure, we have two cross-coupled NOR gates. To understand this better, let us see what we have, the truth table for the NOR gate. So, NOR gate truth table. So, 4 combinations 0, 0, 0, 1, 1, 0, 1, 1, and NOR is actually complement of the OR. So, we will have here 1, remaining 3 places 0. This is the output. These are the inputs. Okay, so now let us say when both S and R are 0. Okay, we have a 0 here and then we have a 0 here. What is the situation? Now, if one of the input is 0, we need to check what is the other input, then only we can identify what is the output by looking at the first 2 rows. So, here let us assume that the previous state here is actually suppose 0. Now, the same 0 is connected here. So, we get a 0 here. 0, 0. The output is 1. So, we are going to get a 1 here. And then, now, this one is connected here and then 0, 1. So, 0, 1, the output remains to be 0. So, what is happening? whatever was the previous state, the same state is maintained. And one could analyze the same thing for the case when the previous state was 1, the same state is maintained. Hence, for 0, 0, whatever is the output, the same value is maintained. What about the case of 0, 1? So, when we give 0 here and then when we give 1 here, so when any of the input is 1, by looking at this truth table, the last 3 rows, when any of the input is 1, the output is actually 0. So, here we are going to get a 0, and then because we have a 0 here, 0, 0 is going to give us, the first row tells us it is going to give us 1, and 1, 1 here, 1, 1 is going to give us, okay, as per the last row in the truth table, 1, 1 is going to give us 0. So, 0 and 1 are maintained and the output will remain in 0 state. So, for 0, 1 we have analyzed that we are going to get a 0 here, we are going to get a 1 here. Now, what about the case of 1, 0? If we give input 1, 0, logically, because this is a symmetric structure, we are going to get 1 here, we are going to get a 0 here, because inputs are exchanged, outputs also will be exchanged. So, output will be at 1, hence we have here 1. Now, let us discuss the last case. Now, for the case when both are 1s, here for the case when both are 1s, now let us assume that the initial state here is 0. We are assuming that the initial state here is 0. So, now we are going to get a 0 here, 1, 0, 1, 0, third row in the truth table tells us we are going to get a 0 here, and the same 0 we have here now, and 1, 0 again here in this case 1, 0 is going to give us a 0. So, let us analyze this once again. Whenever we give 1, 1, whenever we give 1, 1 here, based on the last 3 rows, when one input is 1, only if you know what is the other input for the particular logic gate, then we can identify what is the output. Okay. So, here now if we assume that we have a 0 here, then 0, 1 is going to give us a 0 here, and 0, 1, okay, the same 0 is propagated here, 1, 0 is going to give us a 0 here. Now, what is the issue here? The issue is this: Q and Q bar have to be complement of each other. So, one issue is both cases we are getting 0, right? Hence, usually this is considered as an undefined state. So, latches are widely used in digital systems for various applications including data storage. How? Data storage? Here, when we give this particular combination of input, the output remains at 0 unless an external new signal is given. Likewise, if you want to store 1, then this is the set of input that we are going to give to the latch. So, usually it is 1 bit of information it can store. Then, control circuits and flip-flops. So, widely used in digital systems for various applications. So, how control circuits? Now, based on the values stored, you could trigger something else. Maybe you want to turn on some equipment for certain duration. So till that duration you will maintain a 1. So that's how you can have an application in terms of control circuit. To this latch, if we connect clock, then it becomes a flip-flop. To implement sequential circuits, what are sequential circuits? Sequential circuits are those circuits where you have the combinational part as well as the memory part. For the memory part, we make use of latches. So that's the reason one of the application of the latches are to implement sequential circuits. Using sequential circuits, we can construct state machines and also the memory elements. State machines, finite state machines, like for example, if you want to implement say automatic assembly robot, state 1, suppose, okay, say you are going to bring in the door of the car, state 2 is supposed to attach, right? So such finite state machines can be implemented, and the block in those finite state machine which acts as memory can be implemented by using latch. So we have seen the SR latch, its applications. That's all for today's lecture. Thank you.